Hello, everyone. Welcome back. It's nice to see people back in the room. I know that we slightly lose people through the course of the afternoon because they want to have coffee, they want to chat a bit more, but we have plenty of time for that later. I would like you to all nudge a little bit forward, if you don't mind. We have these wonderful, comfy seats in the front row, and then we can see you. So, oh, thank you. Thank you so much for listening to what I'm actually saying. Thank you. Well, great example there. What's your name? Keval. Thank you very much, Keval. And where are you from? Which okay, well, welcome, Keval from the UK. Yes, so the next session is in space. Thank you very much. In space manufacturing. It's going to be moderated by Mike Curtis-Rouse, actually. He has currently just left the room to encourage more people to come in, but whilst he is not in the room, I think he's not in the room anymore. He's going to run back into the room very quickly. Let me introduce the panel to you, so they will all come onto the stage in his absence. So we've got Mike himself, of course. We will have Hamid Sorgali, who is, as you've already seen today, from Satellite Applications Catapult. Thank you. Yes, you can sit there. You can remove that, and you can just pop it on the table and sit there. And you'll have a central seat. There we go. So we have Hamid Sorgali, we have Paul Holt, who is currently in a parallel session, who will be joining. He's Managing Director at Photocentric. Hubert Moser, Senior Director of Engineering at Flawless Photonics. Michael Kringer from D-Cubed. Guillaume O'Hara, CEO and founder of ArcSpace. Bernard Hoefenbach, you know, of course, Commercialization and Innovation Lead at ESA. So please welcome everybody to the stage, and most particularly Mike, who will lead this session. Thank you.
Thank you. I'll jump to that side. No, we're going that side. No, I'm going that side.
Hello, good evening, everyone, and thank you for joining the panel session on in-space manufacturing. We have designed this panel to cover a number of areas here today. So one of the key themes that we're speaking about, what are the next steps for European in-space manufacturing domain in terms of strategic direction that's required to bring in this area. And the other element is that we've got a very diverse ecosystem within in-space manufacturing. Many representatives here represent that diversity of in-space manufacturing. What is the state of development? And again, linking it back to the strategic direction that's needed to be brought for in-space manufacturing domain. So over the last year, discussions around in-space manufacturing has been gaining momentum, especially around development of a European-wide strategy and roadmap. Now, many may ask, why do we need a strategy and a roadmap for this domain? A very simple answer would be to unify all of the efforts that are going towards development of capabilities over the next decade, and also bring a cohesive approach to development of capabilities, ecosystem, de-risking adoption of these technologies. Now, if you look at the very basics today, where in-space manufacturing sits, it sits within the broader ISAM category, which includes servicing, includes assembly. And over the last decade, it's been servicing, which has been the more mature technology stack. And it's been the area which has received the most attention, government fundings, industry interest. And as a result, we are, and that has been very much linked to the sustainability and security aspects of servicing. But categorizing all of manufacturing, servicing, and assembly together, it neglects the economic potentials of what in-space manufacturing can bring for LEO economy. These are, while they're very complementary in terms of kind of capabilities, however, they've got very different market needs, technology development challenges, different end-user markets. For example, in space manufacturing, within in-space manufacturing, if you look at the diversity of it, we've got in-space production and R&D on the one side, and the very end of the spectrum, we've got in-space manufacturing for space. That includes development, manufacturing of free-form manufacturing in space, where Essentially, you can develop larger structures in space and assemble them, all the way to development of in-space manufacturing solutions that can go into very compact solutions that can change the architectures of spacecrafts, and how we can drive sustainability in that area. However, if we look at the in-space production within in-space manufacturing, it has a huge potential for creating synergies with other industrial segments terrestrially, advanced manufacturing, pharmaceuticals. So in terms of how can we essentially drive development in these areas and not neglect them, there has been the discussion around bringing a specific strategy that looks at in-space manufacturing. Now, the reason for that, we don't want Europe to remain just a participant, but rather how can we ensure Europe is essentially a leader in innovation, has got major supply chain capabilities in this segment, so that in 10 years' time, when we look back at the opportunities we had, we don't feel essentially that we've neglected this area. So in order to get to that leadership and innovation in space manufacturing, which has huge potentials in terms of economic development and also demand for other LEO adjacent capabilities, there are a number of things that needs to happen. We need a strategic capability and technology development program. On the one side, I mentioned earlier, we need essentially to unify both public and private efforts across Europe. We've got different organizations that are leading various activities. How can we unify them around a set of scalable goals, both focusing on technology development, ecosystem? So this all points out that there is a need for development of a strategy. Now, the approach development of that strategy requires essentially, it will have its own challenges, considering it's going to be European-wide. We've got different member states that have got their own space national strategies pursuing different capabilities. So in a sense, we've been thinking about, with our colleagues in ESA, with a number of other industry participants, we've been thinking what would be the practical way of bringing essentially a framework that allows us to develop a strategy and roadmap for Europe's space manufacturing. Very much the thinking is heading towards around development of an industry-led approach, essentially forming a committee of industry players whereby they come together. It could be a small committee of 8 members, representative of diverse capabilities in space manufacturing, of both large and small players, and also different member states. And this committee also works very closely with another advisory board that's made up of essentially technical and institutional stakeholders. We've got European Space Agency, we've got European Innovation Council, we've got member state space agencies. All of these are playing an important role. Now, the reason this committee will be formed is essentially to bring that legitimacy to the approach of development of this strategy. At the same time, the committee will work with the advisory board to ensure that the strategies that are being developed are essentially aligned and informs European Space Agency's programmatic plannings, funding. So essentially, the essence of this strategy is also to influence the next decadal co-funding programs that can come. So here we've got a very diverse panel. I'm going to keep it short, and I'm going to pass the mic to Mike Curtis, who will drive the discussions around the next part of the session.
Thanks, Hamid. I've got a headset, so you can keep your microphone. Thank you very much. And with that introduction from Hamid, I'm always interested by the makeup of the audience. And one of the interesting things about panels is the panel. I've got a great panel here, and I'll introduce them shortly. But the audience is always the other member of the panel. If you're not listening, if you're fascinated by your phone, your laptop, I won't point people out, we've all been there, then the reality is are you getting from this what we want to give to you, and vice versa? So can I just firstly, and do excuse me, I tend to wander around, so if I leave the panel, I'm not ignoring the panel, and I'm not ignoring you. In fact, I'm going to do exactly that now. So I tend to pace, I think, on my feet. If I fall off the stage, that's my fault. But can I just ask the audience generally, in here, the makeup, the breakdown of the organizations here. You're coming from a variety of backgrounds. Probably echo chamber effect slightly. Most people in here are space organizations. And if you're bold enough, can anyone put their hand up and just tell me if you're not a space organization? Again, that's like, wow, that's, can I ask the lady at the front, to my left, your right, what is your organization? Okay. Okay, so different. And I think I saw some hands somewhere at the back. Someone, it's like a black hole at the back. So did anyone have a hand at the back? No, not over there. Anyone over here? Okay, so a little bit in here in terms of breakdown of a few people who aren't in the space industry. So a second question from that, of the space organizations here who make products, so whether that's pharmaceutics, potentially, certainly infrastructure, launch, other spacecraft components, how many people in here have a product you can, I wouldn't say physically pick up and hold in your hand, maybe you can pick it up with a crane, but perhaps you can pick it up with your hand. Can I just have a show of hands again, just to see from a manufacturing perspective, who makes things in here? Not maybe personally, but in your company. Show of hands, please. Gentleman down to my left, what does your company make?
So in space, which is the same, we wouldn't be able to hold in your hand yet, would be advanced materials, but we make satellites. And they're a bit too big to put in your hand.
And I'm guessing by your T-shirt, unless you've stolen it, you're probably Space Forge. Yeah, right. Not stealing T-shirts is not a bad thing. Anyway, enough talking to you for now. Let's talk to the panel. So I'm really delighted to be joined, and apologies for my back to you briefly, but being joined by Bernard to my left, and then the remainder of the panel in terms of, in no particular order, but Michael, Paul, Hubert, and Gwilliam, and I'm going to massacre names, so apologies, I'm British, I'm really bad with names, including English names as well. But moving on, I'd just like the panel very briefly to introduce themselves, and then we'll get into some really interesting questions. And just to keep you on your toes, I'll probably wander off again and ask you questions again, please. So please just stay awake and listen. And if you don't want to listen, if you set your timer for about an hour, dinner will be soon. But Bernard, briefly, 30 seconds, please.
Bernard Hufenbach, I'm representing the European Space Agency in this panel.
That was amazing.
It's going to be hard to do less than that. ArcSpace does manufacturing tools and develops industrial process for use in orbit and out of Earth.
I'm Hubert Moser from Flawless Photonics. We're a photonics company, a little bit with space, but we're using space to create a fiber where Mike will explain us what the acronym means. Basically, it's Zeblan, a very special and nasty material that we're drawing in space, bringing down here on Earth, and then selling it here.
Let's just pause there, quickly tell the audience what Zeblan is, because we're not all material scientists. Well, a couple of us are, but just so we don't forget that point.
It's a mix of 4 or 5 different fluoride salts, basically zirconium tetrafluoride, barium, lanthanum, aluminium, and sodium fluorides.
And there'll be a quiz later. So.
Yes. And it basically doesn't want to be a glass unless, as soon as you heat it up, it turns to become a crystal or a salt again. When you do that in microgravity, things go much slower, which is in our favor, so you get a very crystal clear and nice glass and a glass fiber out of that.
That was a brilliant, transparent answer. Thank you, Paul.
Hi, everyone. Paul Holt, Photocentric. My interest is manufacturing in space. We got a funding for Cosmic Maker, which is a beautiful way to manufacture using LCD and liquid, and you can make polymers, composites, ceramics, and metals. And my interest is the fact that it's autonomous.
Hi, I'm Michael. I'm from Decubed, and at Decubed we are doing in-space manufacturing of support structures for very large flexible solar arrays in order to provide more power to solar arrays for a smaller price.
Brilliant, thank you. So we've got a panel with some really broad perspectives. So we've got companies who are planning to make things, or in Hubert's case, already making things in space, companies planning to make things in space, companies in Paul's case, who are going to make the things which are going to make things in space, and then infrastructure from Grillium in terms of in-space manufacturing, and then organizations like ESA who are going to pay for all of it. Well, maybe not going to pay for all of it. We hope so, but we know that's not going to be the case. But before we dig into some of the meat of this, the first question I really want to ask is, we know space has got huge potential. We're space professionals. We believe it. We have to believe it, because otherwise, why else would we do it? But what is the argument, really, if we're talking to the non-space community, the rest of the world, of why are we going to do things in space? Can I ask, I'm going to ask the audience this as well, so be alert, but can I ask, first of all, Paul, really coming from a perspective of a non-space company doing space, why space? What's the sell for us?
Well, from my perspective, if I want to make anything which has a composite in it, i.e. a ceramic or a metal stuck in some polymer, then the two SGs become an issue. Ceramics typically at 3 and metals up in the teens. And sedimentation means that it's pretty impossible for me to do it isotropically. In space, this would no longer exist. So we could make a better product. But I'm also just interested in manufacturing. And 3D printing has lots of failings to it. It's actually a very small part of the world manufacturing. If you took all the world's manufactured goods and you transpose them as grains of sand on a teaspoon, then additive manufacturing would just amount to one single grain. But when you get in the industry, as I've been, you become a bit obsessed by it and you think it's great. It's actually got lots of failings, and the biggest failing is reliability, which is the thing that all manufactured processes actually have. 3D printing really doesn't. And what I'm most interested in is the fact that we've made it reliable. So if you wanted to make something, if you wanted to make one item in space when you really needed it, the process that I would really look for is the one that can make 1 million of those items on Earth every single time, every day. So that's why I'm interested in space.
Thank you, Paul. That's so very much about reliability, but being able to do something that potentially you can't do anywhere else. And we know that additive manufacturing, or 3D printing, as it's often referred to, is one of those magical processes which everyone thinks works first time. And anyone who's been in the industry knows that it rarely works first time, and it's often not the second or third time either. Michael, just in terms of, from your perspective, why space?
So in our case, we are a space company. And we see actually that space brings us a lot of benefits, actually, for example, Starlink satellites, all these things that we use on a daily basis. And what we like to do actually is to provide even more supports, more services actually for space to get more out of what we can do right now, because at the moment we are very limited to all the launch providers basically, and launching something to space is expensive, and that's what we also get back on our daily life actually, because this also limits what we get for our services. Yeah.
Thank you. Hubert, photonics, I'm guessing there's a fairly obvious answer here, but can you enlighten us?
I think it's an obvious answer, well, or not. Say, what we need for our fibers to get our fibers perfected is microgravity. Now, it depends a little bit how long we need that microgravity. For some elements in our production chain, a second and a few minutes are enough. That's where we, in principle, could even go onto a parabolic flight, a vomit comet, how others say. The operators might suffer a bit, but it's an option eventually. Now, for fiber drawing, that's a process that takes a few hours for the short format fibers that we're producing, so up to 1 kilometer. For the longer fibers that we're tackling in future, it's going to be a week or a few weeks, and low Earth orbit space is then the place to be, as low as possible to not get down in a week, and not too far away to keep the time up there and down here in a logical sense and meaningful. So microgravity is the reason why we go to space.
And from a manufacturing perspective?
Yeah, so on our side at ArcSpace, we're more space for space in terms of in-space manufacturing. The very fundamental logic is you have access to a new location. If you have to bring everything from point A to point B and you're not allowed to transform anything at point B, then you're not playing the game correctly. You're losing so much in terms of performance use of that new environment. I won't go all the way to saying that, well, if we had to bring everything from Europe to the US every single time, then the US would not have developed, kind of thing, but almost. So it's, okay, we have access to a new place, not even with Starship, but more access to the space in general. We have to develop the tools and capabilities to exploit fully that ecosystem. What comes first is another question, which I won't get to right now, but we have to use and develop tools for that new environment.
So it's about an ecosystem, it's about products, it's about having markets and products to serve on orbit. And Bernard, from your perspective?
Well, I think for ESA it's obvious. From the exploration perspective, our mission is to send humans to Moon and Mars, sustain long-term operations there. It's a bit in the future. But without in-space manufacturing, this mission will never happen or not happen in a robust or cost-efficient way. So I think ESA in the long term will be a driving customer for some of those activities.
That's great. And I'm about to wander because I need to point questions and because I know some people in the audience, and I'm going to point at Alex Goodhand. Sorry, Alex, pick on you. Alex, can you just introduce yourself and just give a 2-second kind of perspective of where you see manufacturing in space? That's...
So yeah, for me, it's a very exciting prospect, all this manufacturing in space. No bias whatsoever. I think the UK can be a very strong part in this. An advocate of advanced manufacturing is something we're very good at, which is why I'm interested in it myself. And seeing you guys up there actually doing it as well is fantastic. Am I allowed to ask a question to a panel member?
Is it a short question?
It's quite a short question, actually, yeah.
It's got less than 10 words. You can ask the question.
No, it's okay.
You can ask the question,
okay.
briefly.
So I think it's to Hubert. We're talking about manufacturing as a whole, and you've given a very good example of the Z-plan that you've done in space. It's fantastic. You've done it on the ISS. Do you see the logistics being a limitation? How far away do you think we are from getting, if I'm buying this and putting it on my shelf to sell, how far away do you think you are from launch, platform, return, so I can reliably sell it week on week?
That's a very good question. And it depends a bit what kind of fiber you want to buy. When I'm using the term short format fiber, this is fiber up to 1 kilometer that we're producing right now and selling typically in the order of 20 to 30 meter pieces. That is something now producing that in the last run was about a month. We had 11 kilometers. Then basically we have stuff on stock. And then it depends a bit what kind of fiber you want, which type, and we can deliver that to you immediately. Our moonshot, as we call it, or the longer term goal is the long format fiber, when we talk about at least 2 or 3 orders of magnitudes longer pieces of fiber, thousands of kilometers, 1,500 kilometers, etc. For that, the ISS, as it is right now, will likely not suffice. And we are looking actually on different options, how we can realize such a production system. Likely, we are going to be the only passenger, but we are not going to start developing re-entry capabilities or our own station, stuff like that. There we are relying on all the others that are coming up, and we started to talk with a few of them, and that's going to be a very interesting, I think in the next year we'll see a lot of things happen, and that will also help us to steer a bit how we realize this part of the production that is longer, and when we are also in the, say, few hundred kilos up to a ton of glass that we are transforming into fiber.
Thank you. We'll pivot back. Anyone else in the audience have a perspective in terms of the benefits of manufacturing in space compared to Earth, or an argument you would make to basically to the non-space sectors? I'm just curious, are there any other perspectives out there? Simon, I think I can see your hand in the air. You're pretty good at shouting now, but you've got a microphone behind you now.
it's not just what is made up there, but it's also the processes. Space, there's a lot of constraints when we have to do anything in space, which means that we have to do things more efficiently. We have to do things with smaller footprints that use less power. So it's the efficiency of the manufacturing, not just what's produced, that's of interest with regards to space.
Thank you. Very good point. So we'll return to the panel now, and we'll move into sort of the meat of this discussion, which is very much looking around what are the next steps for Europe if we're going to ensure that there is fundamentally a strategic direction. How is Europe, as a collective, a leader in space manufacturing? We clearly have those capabilities in materials, in manufacturing capabilities, in autonomy and robotics, but how do we apply that? How do we ensure that we're not just a partner, but we're a leader and we're basically trailblazing? Bernard, I'll just ask you a little bit about effectively the sort of strategy and the roadmap for building that capability. Could you maybe just talk to how you see Europe basically positioning itself, taking the phenomenal work that companies like this are doing, but how do we turn this into something that we can forge, no pun intended, basically into something which gets us to the next stage, something which keeps us moving?
Well, I think developing a strategy is a good idea. If I look at the ESA environment, it's a cross-cutting theme. We do a little bit in different program directorates. We're excellent in developing a strategy for exploration because our core activity for this cross-cutting theme sometimes is not so obvious who is driving it in the ESA environment. I can give one example of what we did here in Luxembourg. 6-7 years ago, nobody thought about space resources in ESA. And then the Luxembourg government and space agencies pushed the theme tremendously. So we partnered with them. And now we developed a strategy in ESA, and now space resources is a topic which is well embedded in our program. But the push came from the outside, it didn't come from the inside. So I think if I think like a topic of in-space manufacturing, it's a means to an end. And I think it should be driven by use cases, applications, business plans. And I think there is a point to be made that industry can push it and stimulate this discussion. Ultimately, I think if you want to have a strategy, it needs to be both ways, bottom up and top down at the policy level, because there's so many stakeholders in the European system. We even discussed earlier about dual use application. That's also an obvious topic here. But I think the idea to get just started and push a system and do it quick and have an industry-led initiative could be a very good starting point.
Hamid, we've talked about a lot of this. I mean, the BSGN is very much a mechanism to do that. Could you build on a little bit in terms of what Bernard's just talked about, basically, of that strategy moving forward? How do we build on it?
Yeah, so a strategy needs to cover a number of development activities. And one of the immediate benefits of developing a strategy would be bringing a fresh perspective on the business case of various applications, where we ought to prioritize areas of next decade's investment, where based on our strengths in Europe, also capabilities. Now, accelerators play an important role essentially bringing new innovations to this area, whether from within the space sector, but also within other industries. For example, through the accelerator Photocentric, which is an advanced manufacturing company, purely focusing on advanced manufacturing of different. We were able to essentially identify Photocentric as a high potential business that could adapt their technologies to space based on our understanding. So accelerators should be part of this essentially innovation ecosystem development. They will play an important role of bringing capabilities from outside of the other industries. So accelerators, I think, should be part of that essentially innovation generation ability for us to be able to accelerate their development, mature those technologies, and apply them to the space.
So in a way, we're talking about de-risking as much as anything.
Yeah,
it's commercially de-risking, which if you're an investor, you absolutely want to know your company's being commercially, you're investing in is commercially de-risked. And equally, of course, it's technically de-risked. So really, Paul, turning to Photocentric, being part of the BSGN, Photocentric isn't a small company. Photocentric isn't you and a few 3D printers in a shed at the end of your garden. You're a little bit bigger. Could you just talk a little bit about how big Photocentric is and how being part of the BSGN has helped de-risk taking a step into space where previously your basis was mostly manufacturing for Earth?
Yeah, I actually sit at the opposite end of the spectrum. I make lots and lots of things that are very low priced, not a few things that are very high priced. The umbilical cord that connects me to space is BGSN. So without them, I'm nothing. My interest in developing technology is trying to take ideas and make products from them. You see, there are lots of ideas. I actually think ideas are a bit to a penny now, but good ideas, they're rare. And then with a good idea, you need to make a product from it. And then the product needs to be good. And therein lies a problem, because the product needs to scale. And I spent the last 10 years looking at 3D printing, and broadly there are 4 mechanisms of 3D printing. You can stick little particles together with a laser. You can put some thermal binder down with an inkjet head, or you can extrude something out of a nozzle, or you can stick things together, liquids together with light. And it's the latter one that I have spent most of my time on. But I've seen hundreds of different ideas within those different fields. So 3D printing suffers from multiple ideas with very few that actually work, that can scale. And it's a bit of the same problem in space, because if you want to fund ideas, you need to work out which ones are going to work. And that's very difficult early on, because everyone thinks their baby is the prettiest and thinks their idea is going to go and work. But the reality is, if you put some metrics on it and you try and ask some questions, what does this look like in the future? What would this look like in a stressed environment? And to go to the point over there, what would it look like if it needed loads of energy or lots of mass, or the conditions just wouldn't suit it? And that's what happens with lots of 3D printing. That's why it's variable. Then it doesn't work. So there is a process that we could go through where you could select companies that had ideas that would work. But ultimately, I need to work with BGSN to take what I know is the right technology to make in space, to make it scale and make it happen.
Thanks, Paul. Michael, D-Cubed, your background is space, so you didn't have 3D printers making widgets for something else in a garden shed. Not that Paul does that, but that's not your origin story if you have one. But your background is space, so you know the space industry. Can you just talk a little bit about that? Knowing the space industry clearly has been useful, and I hope by an extension of that you're going to say the BSGN was useful too, not that it was just truly awful and you never want to do that again. But could you just talk a little bit about your experience in terms of why the BSGN has been useful there in terms of your journey?
Mm-hmm. So when I was getting in touch with in-space manufacturing in general, it was like 2018. Actually, never really believed anyone in space manufacturing, and then D-Cubed and BSGN really changed things as they took it serious. And what we did actually is, now in the meantime, we step-by-step de-risked basically our technology. So we had parabolic flights, for example, to see what happens to our photopolymer that we are using for this process, where we could see, this is how the polymer behaves under microgravity. We had a sounding rocket flight, for example, where we could see, vacuum and microgravity has this and this influence on the process. And based on this experience, then we could really see also what's necessary in order to get a reliable process. And with that process, we have pitched this process to you. And we got the chance to implement now an in-orbit demonstration with this accelerator, which is a really great opportunity, because only if you see that this technology is working in space, you know that you also can get your application to work.
And Hubert, you're not a newcomer to space. Building things on the ISS is not something you just decide to do one morning and off you to go spinning your fiber sort of thing. This has been a long program, and it's clearly going to go significantly further into the future, as you were talking about, in terms of just fiber production. Your program's been partially co-funded. It's allowed you to get to a point where you are potentially commercially viable. Can you talk to that?
Maybe a little bit more history. Say, CPLAN has been around for quite a long time. CPLAN in space. There were also the parabolic flights. NASA did there some early tests, maybe almost 20 years ago. And then there was also in NASA sort of a competition where different companies tried to draw fiber in space, and until a few weeks ago, it was still not yet demonstrated that it is viable to do it up there. Like fiber drawing in space, still, there was not a lot of data that was published, and we are about to publish only the results from our mission back in March this year. And we are super thankful that we got the support mainly here from the Luxembourgish Space Agency, who helped us through this long story. We established our footprint basically here in Luxembourg in early 21. We also had the support from the Australian government with the expertise in C-Plan, and of course the US ISS National Lab, NASA with their in-space production application program or portfolio. That was a great, say, network of individual entities that work together. Not to forget ESA, with the technical oversight pushing us a little bit, here a review, and finding a mock-up of the MSG in the ISS somewhere at ESTEC. That was a nice surprise. We had a lot of support, and that brought us to where we are, and we sold our first fiber. Nevertheless, it is still tricky to get the other portion to bring the private portion in, and that is something that keeps us busy all the time. So it's a challenge, but it's also somehow it pushes us to go further into the market, to talk to people, understand which type of fiber do you need. Does it need to be green or yellow? Which size? How long? Stuff like that. If we would have no co-funding portion, maybe that pressure, I will hate myself for that, that pressure would not be there. On the other hand, it's also, it supports the selection of the successful businesses and the less successful businesses. Even if it's a technological leap and it's great and we see that we have a 10 times improvement in attenuation, the business still needs to develop in a way that we can say we can live fully from our fiber sales.
I'm guessing, I mean, lots of people have flight tags. I'm guessing you don't hand out strands of fiber of saying this was made in space and you can take this and attach it to your bag.
Only up to a meter, but no, we are selling fibers. We also produce fiber here on Earth. So basically, we have our machinery also here over there in Wecker in Luxembourg, producing fiber, and it was quite a nightmare to get a draw tower that is about 2 tons and 4 meters high into a little box that is half a meter long, and so space was not initially the big challenge when we started that whole endeavor. It was more like automizing a process that is still here on Earth considered an art. Like you heat up a little piece of glass, you let it fall, you use gravity to start the overall process, and then you thread it through a bunch of wheels. And that was basically the major challenge that we faced. It was not that much space being space, it was more automating something that is considered an art.
So what you're saying is it's not that simple.
Yes, we have a lot of words.
So that's a nice kind of pivot just in terms of from an ArcSpace perspective. Your focus is around infrastructure, basically, and we need infrastructure and we need the capabilities and the facilities to build that. And is that something that you pursued alone, or is that something that you've done in partnership with agencies and other bodies, etc.?
Sure. So our objective is to enable the next generation space infrastructure globally. What we focus on ourselves is the manufacturing tools, the process expertise. So our customers are the designers of those end use cases for space-based solar power, for a large space station, lunar infrastructure. Where we found a gap in terms of complexity, of lack of available infrastructure, was in, okay, you want to develop all those massive impact in space manufacturing use cases or end use cases, space for space or space for Earth. But the road is long, and when you work on terrestrial applications, you have available infrastructure for more generally not just R&D, but like testing and demonstration. And you refine this iteratively, not once, not twice, like more than a dozen times to hone in the process. And then when you understand what your process can do, you can design the end use case. The problem with space is the testbed and demonstration capability is parabolic flights. For microgravity, it's the very busy ISS, hopefully someday space stations, but where the cost is still very, very high. So we found a gap in terms of testing capability for maturing the processes, which is an absolutely required step to get those to those end use cases. Again, space for space or space for Earth. That's really important in order to get to the same way we develop things on Earth, rapid iteration cycles in development, and that's how we believe the growth of the space economy is going to actually be enabled. This being said, I mentioned two things: the capability in production and design and use cases. Those go hand in hand, and I think it's very not often clarified that these are complementary but separate. Designing a space station takes an engineering company, and designing an assembly process that's going to assemble those parts of the designed space station is yet another engineering company, even on Earth. And understanding that and providing resources from agencies, but also from private investment, for a panel of companies that support each other, both on the capability development as well as the end use case development, is critical for, especially for Europe, to be competitive in space manufacturing in general.
So in a way, I mean, where Bernard was talking about basically in terms of provision of capability, initial partnerships with Luxembourg, which led to creations like ISRIC, et cetera. Hamid talking about the BSGN facilitating the growth of new companies, some who may have space heritage in the case of D-Cubed, some in the case of Photocentric who do not. And then others like Flawless Photonics in terms of coming out, but with the support to access, whether that be a drop tower, be it in terms of the experience of accessing the ISS National Lab, right across to basically that support of identifying the different frameworks and different production, whether you're building a station or building components of stations. There's a critical role in there for national agencies, for ESA as a, I don't know, would we define it as a super agency in a way, basically sitting over the top, but all of those activities which then underpin as well, because collectively, the four commercial companies here, your journeys may have been still successful, perhaps not as fast or as successful without that participation. So I think that's coming back, Bernard, to that requirement for that framework. If Europe is going to be a leader and maintain its leadership in terms of in-space manufacturing, we've got to have that robust framework. We've got to have that strategy, which ensures that companies like this are successful. And I suppose the question I'd turn back to you and ask is, are we doing it fast enough? Is it good enough? I mean, the answer could be simply, yeah, we are doing it good enough. And I think sometimes we're quick to dismiss what we do and say, oh, we can do it better. But actually, I think sometimes we should, you know what, we actually do this pretty well. That's not bad. Where do we stand?
I mean, it's interesting. That's already very nice, perfect examples here of successful.
We didn't let the bad ones come.
Ideas. Yeah. I think one reason that we created the accelerators is to accelerate. And I think if I look at the 4 accelerators we created in space production, is a cross-cutting theme, whether it's biotech, whether it's manufacturing examples we have here, whether it's space resources, which is which is providing the materials, and even sustainable food and agriculture as an element of in-space production. So I think it's a good starting point, but that's a bottom-up, right? It's a bottom-up. I think, and the investment from agencies is limited today. I think having a unified strategy in a very short time frame could push a little bit more focused activities in the future. And I think ESA as an enabler, I mean, we have a lot of support now for commercial kind of activities, ESA-wide. I think ESA can play a great role here, not just to facilitate the strategy, but to do more of the things we're doing with the accelerator, which is to enable a demonstration of a use case. And we're coming back to the idea of de-risking technology and opening the door for private sector investment. We can offer flight opportunities to stations, to free flyers, to post-ISS CLDs. In future, we can offer flight opportunities to the moon. And then if the industry invest in their top-notch payloads, I think that could be in itself a fantastic partnership. And again, ESA can also be a customer because some of these applications serve ESA primary mission purposes as well.
Great. Hamid, I think you should swap with me. I keep having my back to you, so I want you to sit there. No, you sit there, because I'm going to throw another question back to the audience. Show of hands, please. Who thinks we're doing things well? Just want to see, is it a split? And you can't, it's a yes or a no, basically. So I want to see who thinks, from an in-space manufacturing perspective, Europe's doing a pretty good job. Show of hands. Okay, that's really disappointing. We're clearly not doing well. Sorry, panel, this isn't good. And can I just have the equivalent show of hands just to make sure that you were listening to me? Who thinks we're not doing it as well as we should be? There are a bunch of people here who are abstaining. We'll hunt you down later, but okay. Interesting split there. Right, so general consensus of the audience is they don't think we're doing it that well. So what should we be doing better? What are we missing in terms of, is it architecture, is it infrastructure, is it flights on vomit comets, is it something else, is it top talent, do we not have the right skills, is ESA not giving you enough money? If you ask Bernard afterwards, he'll give you a check. But any of the panel, who would like to respond to that?
I can start maybe with a simple comment. It's always the chicken and egg problem. As long as the use cases are not clear and the market side adoption clarity is not there, then why would anyone want to go? So ESA will put a little bit of money in a bunch of pots, which is the natural thing to do. There will be limited funding, so everyone's stifling to, it's no acceleration. So that was my general comment, no answer.
Wave a wand. We can wave the magic wand, and you can have anything you like. And it needs to be related to space. It can't be anything. What do you have? What do you get? What makes the difference? What takes you from where you are now to basically being, hell, we're doing great. You know, we've got so many customers, you know, we're just going to retire early. What's the missing thing for you? Or is it customers?
I would say, actually, knowing that in 50 years, these are the applications, not for me, but for everyone, in 50 years, these are the applications that make the world a lot of money. And that way, everyone is convinced and knows today what to put the money on. And then in like 5 to 10 years, all of that will have come to fruition.
That's a pretty smart answer. So it's a little bit of crystal ball gazing, which says, what does the wider ecosystem need? And then work backwards from that. So who are the customers? Remainder of the panel, any comments? Michael, I think you're on the cusp of saying something there.
Yes, exactly. Well, we also would need to have ESA, for example, that takes the risk to test in-space manufacturing first. For example, for our solar array with the in-space manufactured support structures, it's quite of a risk to be the first that uses such a product. And I see actually a space agency also as, the responsible institution to take this risk first in order to de-risk it. Yeah.
Hamid.
I wanted to say that I think obviously it was interesting to see that not many hands were up.
No, I know. I don't think they're particularly enthusiastic. We can work on that.
So I think one of the things that could be done more effectively to actually inspire momentum in this ecosystem of in-space manufacturing would be a more joint collaborations between institutional stakeholders, European Space Agency and industry, whereby the relationship is not just based on funding, but rather co-designing future missions. You know, we could, for example, we've got the Solaris program, which is a significant long-term program which inspires various
Just tell me what
companies.
Solaris is, just remind me. Lots of acronyms.
So Solaris is the European Space Agency's development program towards building space-based solar power. Now, these are massive structures in space that create power back to, the beam power back to Earth, but the technological challenges of developing that, bringing new capabilities, supply chain behind that. You know, it's various issues that needs to be addressed, and a program like that for in-space manufacturing would inspire better collaboration between industry and European Space Agency, where in these missions, such long-term missions, we can address a number of technical challenges as well, demonstrations, infrastructure, bringing new players. And that mission can be the anchor whereby we can essentially inspire and have more happier hands up, hopefully.
Well, that's a good point. We'll do that next year and see if there's a difference. So, I mean, I'll just push back to the panel firstly. Firstly, Paul, customers, if ESA said, and not just ESA, if other space agencies said, on every space station that we have a program with, etc., we want to see a cosmic maker on board, presumably that would be a good thing, and that would give you the confidence that you build more, you continue developing and progressing your journey in space.
The obvious answer to your previous question was money, but everyone says that, don't they? Or just lots and lots of parabolic planes going up and down all the time. It's a very weird industry. I mean, if I was in a different industry, I would just find a customer. That's it. If I was selling to the defence industry, I could find lots of customers, not just the national body that, like the MOD in the UK, but space is different. So we really do need you. And if you said yes, then we jump. But if you don't, well, we really can't get off the ground at all.
Bernard, I mean, I think that's an interesting point from Paul. I mean, Paul's coming from effectively a very non-space industry, and I think you're enjoying the journey so far. I mean, you haven't quit and given up.
You're a great set of people. You're all here because you want to be here, not because you're getting paid, I assume.
That's good. They don't like me, but you tell them that. But from your perspective, Bernard, putting companies like Paul into the space sector, bringing new capabilities, I think that's pretty key. Basically, that's building an ecosystem with people who aren't just space people, which is making, in a way, space non-space.
I think that's clean objective. I don't know whether you listened to the panels earlier where the topic of focused science came up, where we want to have research question, whether it's technology or science, to help us addressing our challenges. One of the key objectives is to engage non-space industry and not to reinvent the wheel. But in order, looking at from the issue of ESA, why we're maybe not doing so well is, I think in-space manufacturing is a bit a niche topic still in ESA. Probably I don't know even a handful of...
Why do you think that is?
I probably don't know even a handful of experts in our ESA environment really working on it actively. I think one first step we should do is to give more visibility to the potential of in-space manufacturing and how it impacts all the things we do in space, and also linking it us to more terrestrial ecosystems. One thing we did here in Luxembourg, which works very well to give it visibility, is to establish a European Innovation Center for Space Resources. Not an ESA center, but it gives the whole topic of space resources in Europe a lot of visibility and makes Europe even appearing as a leader, even so now they invest 10 times as much as Europe invests in this today. So one thing ESA could probably help with is to give it visibility and really reflect about the potential of in-space manufacturing. Still, I think it's the industry which has to find the customers and create the business models to make it work in the long run.
So a centre for perhaps a ESA co-funded, co-sponsored, doesn't have to be funded per se, but a centre for an Institute of Space Manufacturing or something, but something which helps address some of those challenges. But I think, Paul, drawing on your point, it's about customers, and indirectly customers equate to money. Hubert, flawless photonics, you've got big challenges of making fibre and things, but the market for Z-band has always been perceived as very large, assuming you can make it in very long lengths. If you can make the fibre in sufficiently long lengths, do you think you'll have a problem finding customers, or do you think you're going to be in one of those, relatively privileged positions where you've got so many customers at your door that you just can't make enough fibre?
What we see now is, even with the shorter lengths, there are a couple of companies that are saying, okay, there's a lack of production of specific fiber. We are not yet there to produce enough the type of fiber that is demanded even in shorter lengths. On one side, for the longer fibers, that's a point where we also need to slowly answer from a regulatory point of view. All our fiber communication here on Earth goes along certain standards at a certain wavelength, 1550, and there is a huge, all the peripherals around it have been developed over a certain amount of time, perfected to the physical limits now of silica, of the typical glass that we know. And to change that will require also some pioneers, so larger partners that lay down a cable between a continent and an island and show, okay, you can transmit that much data with the same amount of fibers and the same length of fiber with less amplifiers. So until we are there, that we are selling our thousands of kilometers in one cable, basically, it's going to be still a walk. We will still need support there. For the short format fiber, which we are looking at right now, where we're trying to slowly build up also our customer base, it looks better. And the idea is also with the short format fibers, we're also changing or developing in a way or the other the peripherals for the long format fiber, like an amplifier that works in a different wavelengths. So that's the approach that we are trying to follow. And it's still tricky. Nevertheless, ESA is not going to be a customer for that. That's pretty sure. There we are rather talking about telecom and mobile, basically network providers.
But that's probably a good thing because, I mean, ESA's big, but the telecommunications market is, I would suggest, slightly larger. And having a big market to address, which isn't, I mean, telecommunications clearly is space at some level, but it isn't purely space. So having a big market, a big customer base has to be attractive. That has to be attractive from an investment perspective. That has to be attractive effectively from finding the right talent, and certainly in terms of finding the right partners as well, because there aren't many Z-band companies, are there? I mean...
There's not a lot. There's basically, I know 3 terrestrial ones that produce C-band here on Earth. There have been a few attempts to do that in the space station with limited success, and thus far we are one of the only ones that produced what we call commercial amount of fiber on the station. Nevertheless, this had to be proven first. All our successors that also tried it on the station didn't achieve that much of fiber to be able to measure sufficiently enough fiber and show, okay, it's stronger, the attenuation is really as promised or as indicated by a little piece that was that size in a vomit comet 20 years ago. So we had to get out of this experimental scientific branch before there is, say, a strong customer commitment coming in saying, hey, I need 50 pieces of the 200-meter fiber and 100 pieces of the 500-meter fiber. We are right now in that stage where we are developing that. And it took quite an effort, and we are thankful to all the others that tried it before and that pushed also agencies in that direction to support it. Yeah, but it's still not done.
The worst thing is to have no competition. I'm going to go and point at some more people, and then I'm going to come back because I want to pick up on the conversation about stations, because that chimes in quite nicely with the earlier panels talking about stations. So panel, just start having a think about stations and where you make things. Because I spotted SpaceForge earlier. SpaceForge, sorry, unless your raison d'etre has changed and your whole product has shifted to making cookies in space or something, I don't think it has, but your focus is on making semiconductors in space. That's at least one of your products and one of the things you're looking at. Would you mind just commenting in terms of where are the barriers for you in terms of basically the opportunities? I mean, is the barrier lack of infrastructure? Thank you very much. Is the barrier lack of infrastructure? Is it lack of customers? I'm guessing, there aren't many companies out there who are planning to make semiconductors in space. So would you mind just talking a little bit to that?
I can do. I caveat it with the fact that SpaceForge has a space side and a semiconductor side. I'm very much on the space side, which is why I'm here, but I know a little bit about it. I would say that one of the things that people don't think about is the supply chain. So something that I would say blew my mind about the semiconductor industry is that these materials are non-fungible. So you can't just say, well, I'm buying gallium nitride from over here and now I'll buy it from over here, because you have to retune your whole process. So there's a lot of work that's been going on from my colleagues in business development in SpaceForge on the semiconductor side, building those supply chains, finding the partners, preparing the projects to get further down the supply chain, then prepared for materials that they haven't seen before. So that alone is a big barrier that I think a lot of people wouldn't normally think about. You can't just make it and then sell it. There's a long process that has to be done. I can carry on if you want me to
No, that's pretty good. That's a nice soundbite in terms of thinking about the wider supply chain. So it's not purely necessarily about funding, but Paul's not going to turn down any money, basically. And additional vomit comments are always welcome, at least if you're payload, perhaps not people. So there are benefits to that. But this is an interesting comment about the supply chain. Where you procure something, you can't necessarily just go to Amazon and say, I'll have 10 of those and pull it from 5 or 6 different suppliers. Anyone else in the audience making or planning to make pharmaceutics, materials, alloys in space? Anyone else out here? Can't spot anyone. Fine, we'll go back to the panel. So back to the panel, questions on stations, manufacturing, places of doing things. That's part of the infrastructure, it's part of the ecosystem. This morning we heard from VAST, we heard from Axiom, we heard from Starlab, we heard from Orbital Reef, we heard from the Exploration Company and Northrop and Thales talking about all their various options and ways they're planning to do things or ways they are actually doing things. Can I turn, Michael, to you first of all, in a way, because you don't necessarily need space stations per se. In a way, they are potentially customers. Where does your business model align with the future stations, which are in theory coming online, and perhaps to an extension where the ISS is right now?
So space stations need a huge amount of power, basically. So the solar arrays for the ISS, they are really huge. I don't know, I have any numbers yet here. Yeah, here a product that we develop would have definitely, would fit for the application. And we actually use also the space station right now as we send it a material sample to the International Space Station in order to test the aging capabilities of the material, because we need to make sure and de-risk also that the material withstands the space environment over a longer period of time. So also for us at this early stage of development, it's pretty important to have access to a space station in terms of having it as a test bed. Now on the material side, but also for the process side, as it would be also nice to test the whole process on the space station can implement changes on the fly on the space station. That would be great, actually. Yeah.
Thank you. Hubert, the ISS is probably got maybe another 5 or 6 years of life, if we're lucky. Are you planning to jump ship early? Is there? I mean, you probably can't share that, but are there options there? Are you going to do a kind of Space Forge version where they have their own factory, or VADA doing something similar? Or have you got deals in the making with Axiom, Starlab, everyone? I don't expect you to disclose, but where are you going?
That's a very good question. Basically, right now we're going 2 paths. One is to use the ISS as long as possible, particularly for the elements where we still expect a little bit of experimentation, like the next step of, say, we're also looking into casting glass, forging glass in a way or the other. That's going to be likely something that we still do on the ISS. But in parallel, we are looking into all the options that are out there. As I said, we're not going to make our own heat shield. We're not going to build our own station, need a capsule. So what we're looking at is to talk to all these elements, not only the stations, but also the capsules that are going up there and spending some time in low Earth orbit, and see how that fits from a mission profile to the portion of our production chain that we are looking at. If we are looking more at the shorter duration elements, like casting some glass or drawing some specific fiber at the short lengths, we might probably go to a quick turnaround solution, like a capsule that goes up and down from, I think yesterday at the New Space Europe, we heard a couple of them. If we are going to, say, a longer fiber, likely it's also going to be a capsule again, but then for custom-made fiber, where we also want to, where we're not that dependent on a quick turnaround, we might also go onto a, say, production section of one of the stations that are emerging. Although I'm not yet sure to what extent those stations really will be built like for a manufacturing place. I got a little bit the impression this morning, don't get me wrong, but there's I think these 3 pillars that were there, and the manufacturing, at least from some of the guys that were on the panel, was put at last and not at the highest, say, maturity point of view. So I have the impression that these stations are not necessarily made as production facilities. At maximum, we'll see probably a little section of these stations that are made, optimized for autonomous production. Everything else I would rather consider as then either a capsule that goes up and down, does production autonomously, and comes back with the material. Maybe a more sophisticated version of a station would be an autonomous station, staying up there, being served by a resupply vehicle that hands over raw material and takes in produced material and then brings that down while the autonomous station stays up there. But that sounds to me as technically the most challenging portion. Not only proximity operations, etc., but a bit more handover of internals of a...
It's a good point. Bernard, just come to you on that point in a way, because a nice segue sideways is future space stations. It sounds like that in order to drive in space manufacturing, we're going to need production capability on orbit, and clearly companies can have their own independent modules, capsules, which we come back. That doesn't necessarily sound that's a particularly long-term sustainable waiver from a business model or indeed anything else. Do you think we should, I mean, does ESA need to have production capability on orbit to do and facilitate the growth of companies exactly like these?
Well, I mean, if you look at the ESA reasons for low Earth orbit, it's not production today. It is maintaining our astronaut competence, having regular astronaut flights, de-risking deep space mission in terms of health.
This would be quite different. This would be a shift.
I think it's different, and I think what is very important that the reflections are currently ongoing, how ESA and Europe position itself in the scenario post-ISS. What we know today, and they have quite some support, is to invest in cargo return services, because it's also a step towards one day, if politics wants that, a crew transportation system. But beyond that, all the discussion is still ongoing. And I think what I see in all the ideas which are presented today and tomorrow, that there are lots of different offers on the table potentially. There are these very small, specialized free flyers with return capability for one particular application. There's the idea to create automated platforms. There are the cargo ships, which can do science and production on the way to ISS, could act as free flyer, and then there's a big CLD. So we see kind of an architecture emerging. And the interesting question, how is ESA positioning itself there and what should be enabled? And in this context, I think what would help everybody is to get more clear requirements from the market, what is needed. Because you said you can use more or less everything because it depends on the specific application, and that's maybe different. So I must say today the commercial use case requirements are not driving the institutional discussion right now, but it could be interesting to capture those more clearly.
Thank you.
So you need to be very fast in developing the strategy. You have 2 months.
Well, you've got a deadline, Hamid, 2 months. We need a strategy which is going to work. Very briefly, from ARC's perspective, I can see that there's an opportunity there for more infrastructure for stations, etc. 30 seconds quickly, just in terms of where you see your role with stations in terms of enablement or indeed anything else.
Yeah, absolutely. One of the examples that was mentioned in the morning sessions was satellite production in those space stations. And when you have the building on Earth, then you just have to add the processes inside, and then you can start churning out interesting stuff from it. One of the use cases we're strong believers in is actually final assembly of IKEA-style satellites. Not satellite as a kit, but the platform is automated, and you have the right processes inside, and you transform once again the spacecraft architectures for conventional applications and potentially new ones.
Thank you. Paul, from a cosmic maker perspective, obviously the market is selling cosmic makers to space stations to make more things, which might be satellites in this case, IKEA style. Do you see space stations as partners in terms of giving them capability, or effectively customers just basically buying cosmic makers because everybody wants something on board which makes everything?
Yeah, I guess I'm ambivalent, really. I'm still to anyone, I suppose. The problem for me, of course, is that you don't really need to make anything in space today. You could just take it up from Earth, and if you want to make something in space, it better be better, like yours, to make it worthwhile. I'm really interested just in enabling space manufacturing, and to do that, you do need to have the right mechanism. And that's the problem. It needs to be autonomous. You've got to have something that you click a button, you send a data file, and you know you get a product out, and you know it with absolute certainty. That's the problem, and that really doesn't exist in any other system that I can see, other than the one that we've worked on. So that's my answer. We need BGSN to give us the money to enable it. I can't see that there's any immediate advantages of making something in space to make a better product, but the reality is you have to go make a lot of products, and then you'll find out which one is better in space.
Got you, thank you. Recognizing I have glaring, I have a question, so we'll take that question and...
Yeah, hi, Mike. So Rick Mastracchi here, my group operates the Cygnus spacecraft, and a lot of great comments. Bernard, you just said something that hit the nail on the head in terms of, I have a vehicle, huge volume, size of a space station module. It could stay up in orbit for years at a time. It has power, it has everything you need. I'm interested in understanding what you guys need. What I'm trying to do is I'm trying to understand what you need for in-space manufacturing. You say the ISS doesn't do the job. I got a vehicle that can go to an ISS, go to a station, crew can get involved, or could fly away from the space station, like I said, for months or years at a time, and keep the crew safe and not disturb your manufacturing process. But I don't have requirements from you. I don't know what you need from power perspective. What do you need from a thermal perspective? What you need from an environment? I don't know if my vehicle does what you need today, or I need to add one device to it and it does everything you need. So we do need to communicate more. Otherwise, you guys are not going to get what you want if you don't tell the folks who are building the infrastructure. And that's what I am trying to do right now, is figure that out so that you could utilize, and let's not be an Earth-centric economy. Let's be a space-centric economy where we build these things. And it doesn't always have to be built inside a capsule. You could use the infrastructure of space stations and the up and down mass that those space stations are utilizing.
Thank you very much. Anyone just want to comment briefly?
Maybe I have a very specific requirement, but maybe in your case, the Cygnus is a great piece of engineering, and we actually also went up with that. What we would need definitely is to also have the capability to come back. And that's one requirement that I would hope that you guys are also working on, but I'm open to discuss a bit further.
It doesn't have to go up and down on the same vehicle. What gets processed in space does not have to come down on that same spacecraft. So there's an infrastructure that's being developed.
You're right. That's why I said for us it's a very specific case, because we want the produced elements down here on Earth. So I think for the others like yours, it's more a matter of power requirements, probably the amount of mass that you need to get up in order to feed your stock and produce actual structure. So I think that it's a little easier as the elements that go up remain up there. For us, it's a bit tricky.
Michael, did you have a point on that? I didn't notice you were just waving your microphone. You can say no if that's the answer.
I have no point on that.
You've got no point on that. Were there any other glaring questions from the audience? I've got two at the front. Alex, you can probably shout. In fact, the microphone's inbound.
So it's been mooted a couple of times on here about space solar. There's some other aspects on there as well, whether it be data centers or others. Do you think these are required from an agency to stimulate the market, or do you think there's enough impetus in the industry at the moment and enough agency support and other support available for you guys to grow and in-space manufacturing to grow, or do we need that focus? Do we need that alignment?
Who would like to take that one?
I think it was mentioned before from you, Hamid, maybe developing, for example, space-based solar power has multiple dozens of enabling technologies for it that have transverse use cases on so many other things that you mentioned. So finding an excuse to develop like those capabilities, not use cases, capabilities, then trickles down and accelerates the adoption of everything else. So definitely useful to have, but then with limited budgets, you have to start with something. Do you go for one flagship mission or 3 sub-flagship
So good
programs?
to have the drivers, but have to operate within the boundaries of reality at the same time. Yeah.
But it makes sense and gives visibility and motivation from non-space industry people as well, which you mentioned multiple times, not today maybe, but over the years, Hamid.
Thank you.
One thing I just
Go
wanted
ahead.
to add, Alex, you mentioned what would be the role of agency if rather there is, for example, already commercial entry in some of these areas. I think, well, I can't speak for the agency, but what we've seen other models around the world, what we've seen in terms of other models that are emerging, agency plays a de-risking role in some of these technologies. Obviously, some of these are very, very, very low TRL, although we know the economic potentials of these major projects and future technologies, there is still major risks for participation of the terrestrial industrial sectors. Let's say the power sector, the investment coming from the commercial side. So agency plays that de-risking role. So I think agency also has a role to continue to play enabling these technologies. We've seen similar models working, public-private partnerships working in the US that have enabled not only emergence of essentially maturing of technologies, but also emergence of new players that are very highly capable driving then those technologies. I'm not sure if Bernard, you had any comments on that, on the role of agencies, essentially de-risking technologies.
I think I said it earlier. I think when it comes to de-risking use cases, that could be a core function of ESA, by in particular providing flight opportunities and demonstrating your innovation in space. I think that would be a nice partnership, yeah.
Thank you. Pretty much at time. Were there any other questions in the audience? Gentleman at the front. I think a microphone is on its way inbound. I'm going to get bad looks from the organizers shortly, so please.
My question's really around additional value, right? So I think when we talk about manufacturing, I think we think very much about the product, the material, and the clear difference between what we could make on the Earth and what we make in space. But in the process, there's a lot more additional value, like if you reduce the inspection, verification, and validation, which is also an incredible cost that we normally have to do. But with more automated and consistent processes, do we count those benefits when we're kind of communicating the value improvement to the greater world?
That's a really insightful point, and it was a little bit about the supply chain one in the same way. That was something which I don't think we often capture. I think maybe asking Hubert, I mean, basically from a photonics perspective, there's a lot of processing in there. Is that value captured, or is that just something which is just assumed, but we don't think about?
I don't think that we value it enough or promote that enough, but I think I mentioned it a little bit earlier. The fact that we went to the ISS forced us to automate things that are not automated here on Earth. And so with the copy of the machine that we have here on Earth, we are able to produce glass fiber at a fraction of the cost compared to that huge draw tower that is a very manual and the arts basically. And that was if you want, it was a side effect of going to space, because we were forced to develop something that is remote, that you cannot always control, that needs to operate autonomously, needs to recover itself. So a pretty autonomous system. And I think that's one of the benefits when we are doing things that have to operate in space. We are doing that in a way that it's quite autonomous, and that in itself has a value here on Earth when you say spin it back from space into terrestrial applications of varying applications.
Thank you very much. We're 5 minutes over, so we'll conclude there. Can I thank the panel, Michael, Paul, Hubert, William, Bernard, and Hamid. That's been a great run through in-space manufacturing. Just before I wrap up, firstly, let me just ask the panel literally to put your hand up. Do you think that in 2035, Europe's going to be leading in terms of in-space manufacturing, or do you think we're going to be lagging? Hold your hand down for lagging, hand up for leading. 2, 3, okay, we're 50, 3.5, okay, we're slightly better over 50% audience. Hands up in 2035, is Europe leading in space manufacturing, or are we trailing behind, having failed to realize our ambitions? Please, the show of hands. Well, this is not looking too good. I mean, it's possibly because you're, still about 40%. Maybe it's because you're hungry. I don't know. But can I thank the panel? Could I please thank you for listening and participating, and hand back to the organizers. So thank you very much.
Thank you so much. And thank you for your tremendous energy as well. Thank you so much, everybody. Thank you. Well, I have the great news now that it is almost dinner time. And I think we have some slides behind us, very soon. The dinner will be just opposite in the Sofitel opposite. I'm sure many of you are probably staying there. It will start at 6:30, so we can wander across there soon. It's 190 meters, somebody told me. And what's very important is to get the correct entrance. So I don't have a pointer, but if I, obviously you can see where the entrance is. If anybody's staying in that rectangular building, that's Mama's Shelter, and we're over here, so one has to cross this way, which is, a main road, quite a tricky one to cross, but it's possible. And so it's directly opposite. I'm sure you can all find your way. If you can design things in space, you can find yourselves across the road, no problem at all. Other news, somebody has mislaid a bag. We think it says Pixie Mood on the bag. It's a black bag. It was in the delegates room downstairs, and so that will be brought to reception. And if anybody hasn't got a ticket for the dinner but would like to join and get themselves a ticket, there are some spaces left, so they can also go to reception and ask for tickets. So with that, that's the close of today. Thank you so much for still being here and being actively participating in all of the conversations. Thank you. That was a little bit preemptive, but thank you very much. I will be going very, very shortly. Tomorrow we'll see you again in the morning. So have fun tonight, but do sleep and be back here first thing in the morning. Thank you.